Welcome to The Explainer. Today, we're going to crack open that AI black box. We're going to look past all the hype and try to figure out how these incredibly powerful systems actually learn to do what they do. You know, most of us have played around with large language models like ChatGPT, and the stuff they can do is just amazing. But for the scientists actually building them, one of the biggest mysteries has always been how they develop these skills. It's kind of like watching a genius at work, but you have absolutely no idea what's going on inside their head.
So to solve a puzzle this massive, researchers decided not to try and read the AI's whole mind at once. Smart move. Instead, they focused on just one very specific, and it turns out absolutely crucial skill, recognizing patterns.
See, deep down inside the model's neural network, this skill is handled by these specialized little parts called induction heads. You can almost think of them as tiny circuits that are just experts at noticing a pattern, like A comes after B, and then predicting that the next time they see a B, well, an A is probably right around the corner. This is like a super fundamental building block for learning. Okay, but that kind of just kicks the can down the road, right? The real question for scientists was, how do these critical induction heads even form in the first place? Where in the mountains of data they read do they learn to build this one specific, vital skill? To figure this out, researchers had to build a completely new kind of tool. Seriously, think of it like a detective's kit, but one designed specifically to trace an AI's skills all the way back to the scene of the crime, the original data it was trained on. It's this framework called Mechanistic Data Attribution, or MDA for short. What it does is pretty incredible. It basically lets scientists become data archaeologists, digging through these massive digital landscapes to find the exact bits of data that built a specific circuit inside the AI's brain. So how does this MD thing actually work? Well, it really boils down to 3 key steps. First, the scientists pinpoint a very specific skill they want to understand, in this case, an induction head. Second, they trace it backwards to find the data that had the most impact on creating it. They use a pretty complex statistical method for that. And then, finally, and this is the important part, they test it. They run an experiment to prove that the data they found is what actually caused the skill to develop. All right, so the team had their detective kit ready to go. They pointed it at these induction heads inside a bunch of AI models and pretty much asked, okay, what data created you? And the answer was really surprising. It wasn't Shakespeare. It wasn't complex legal documents. Nope. The data that was most influential, the main catalyst for learning this core skill, was made up of highly repetitive, almost noisy, or what you might even call garbage sequences. I mean, we are talking about stuff like XML data files, computer code with the same functions over and over, scientific papers formatted in LaTeX, database entries, and even these really long strings of what looks like totally meaningless repetitive text. So the common thread weaving through all this different data is just intense, predictable repetition. These structured formats are like the perfect workout for an AI that's trying to learn pattern matching. It's like a weight room for building these induction head muscles. And the effect is incredibly focused. It follows what's known as a power law. So think of it this way. A few superstars have a massive impact. A tiny little fraction of the data, just the top 10% of these repetitive samples, was responsible for about half of all the learning for this skill. That's wild. Okay, but finding this connection is one thing. How do you prove it's not just some random coincidence? Is this repetitive data actually causing the skill to form, or is it just kind of related? To find out, the researchers ran a really crucial experiment. The logic they used was super direct and, honestly, kind of brilliant. They thought, okay, if this data is really the catalyst, then taking it out of the training process should slow down how fast the skill develops. And on the flip side, if we add more of it, that should speed things up. Make sense, right? And here it is. This is the result, the smoking gun. The green line shows that when they added more of that special repetitive data, the AI learned the skill way faster. The red line shows that when they took it away, the learning process just lagged way behind. This is the proof. So just to be crystal clear, removing that influential data actively held the AI back. Adding more of it put that learning into overdrive. And just to be sure, they tried changing random data, and nothing, no effect at all. This proves a direct causal link. That repetitive, noisy data is the cause.
Now, this discovery is way more than just a cool academic finding. It has massive implications for how we build and control AI in the future. Because these simple little pattern matching skills, they are the foundation for something so much more powerful.
You see, these simple induction heads are believed to be the fundamental building blocks for one of the most powerful abilities of modern AI, in-context learning. That's the magic you see when you give a model like ChatGPT a few examples in a prompt, and it just instantly learns a new task right there on the fly.
And here is the final piece of the puzzle, where it all comes together. Using their MDA toolkit, the researchers gave us the first direct causal evidence for this theory. When they used their data tricks to make the induction heads form faster, the model's ability to learn in context also got better. It's a direct, measurable connection.
So what's the big takeaway from all this? Well, that famous black box is finally getting some light shown inside. We're moving away from just watching AI happen to being able to perform targeted surgery on its training data to actually shape how it develops. This opens the door to engineering AI that's more reliable, more controllable, and ultimately safer for all of us. And all this leaves us with one last really fascinating question. Now that we can essentially identify and manipulate the DNA of an AI's training, we have to start deciding what skills are we going to choose to enhance, and just as importantly, which ones might we decide we want to engineer out.